So, I'm just trying to think. I might do just a recap of the notes from Friday, just kind of recap what we were doing before I dive into the new material. So just as a reminder of what we've done so far, we looked at the first IR spectra. And remember, from IR spectra, they're going to tell us information about the functional group. Actually, let's not use the blue because you guys are used to blue as something else. We'll use orange. So this is question 1 in your booklet. It should be the first page, correct? All right. So this one here, this is my IR spectra, and IR tells me functional groups. So that's the first thing to kind of keep a note about. Remember when we were talking about IR spectra, I suggested 2 things to help you navigate, and then trying to use the resource sheet to help figure out what functional group you guys have. So, I don't have that in front of me, that's okay. So first thing we should be looking at is 1700, so that's 1500 here. So 1700 is roughly here. And what I look at for 1700 is I'm looking to see if there's a sharp peak, or actually it's probably a trough, is a better word to describe it, that's going quite a ways down, probably well over 50%, somewhere between 70 and 80, not 100% kind of area. What that tells me first off is if there's a carbonyl group there. So since I see nothing there, no carbonyl. And remember, what I'm marking in red is the achieved requirements. You good? All right. Next thing I look for as my reference point is the CH, and that's roughly at 3000. It's going to look like this little guy here. So I labeled this as CH. We know all organic molecules have a CH there. And what I'm basically using that is a reference point for whatever is left to it to see, do I have something to the left? What I see here is another big trough, and if we look at our resource sheet, it can give us, a rough idea of what it is when it comes to the range. You can also look at the shape of it as well. So we spent a lot of the IR lessons just getting used to looking at the shapes and identifying it. This one here is my OH shape. So based off the 2 bits of information here, I don't have a C double bond O and I have an OH. The functional group that I'm looking for is an alcohol. And that's all I need to do for the achieved, is just figure out what I see and do some labeling. So Charlie, I know you missed that lesson. It's worth watching that video just so you can get to learn what these shapes are. This is probably the hardest thing that you need to do for the achieved. Everything else is dead easy. Okay? All right. Next thing we talked about then on Friday was our mass spec. So I'll label this bottom one here, mass spec. This tells us a lot of potential different information. The first bit of information is it's going to tell us the molecular ion, which is the mass of the molecule. And from that mass of the molecule, we'll be able to figure out a number of carbons. So that's the first thing that's going to be able to tell us. The second thing the mass spec will be able to tell us is, and we'll see it later, I'm going to teach it probably next week, is about the structure of the molecule based off of the fragment patterns. But again, that's going to be next week, and it's also going to be what you need to do for excellence. So do keep that in mind and don't stress about it if that's not what you're aiming for. When it comes to what I need for the achieved, is I need to make sure that you're labeling 2 things, and I only need one of the 2 things labeled correctly for the achieved. I want you to label both just as a backup. So the first thing I need you to label is the highest peak. So when I look at all these guys, I'm basically looking to see what has been labeled as my 100%. I circle it and I label that as my base peak. That's the easiest one to find. So basically whatever is 100%, that's your base peak. What that tells you is that this is the most common fragment. I'll add that as a note, but you only have to start worrying about that if you're aiming for that excellence. We good? All right. Second thing that I want you to label for the achieved, even though I only need one of the two, is going to the molecular ion. In some cases, the molecular ion is going to be too small of a peak to be able to recognize it. So in this case, that is an example of something that's too small that is going to be recognizable. So I will give it to you. So the molecular ion is the peak that is most to the right, because that tells me it's the largest of the ions. Yep.
I'm looking for Charlie McMillan.
All right. So, like I said, the one that is most to the right is the largest not even fragment. It's the largest mass because it's the unbroken fragment. In this case, this fragment's not very stable, this molecule is not very stable, so I have labeled it for you. So that makes your life easy when it comes to the assessment, because you just circle that one there, and you go that this is the molecular ion. Now, in some other questions, let me grab them for you. Grab my few here that I have. That's 2, 3. I don't know how many I've gotten. Let's grab this pile. So in some of them, it's going to be really obvious, and I won't give you a hint. So like in this case, when I'm looking at it, this is question number 2. I see that this is my base peak because that's my 100%. And then the molecular ion, in this case, I haven't labeled because it's big enough that I think you'll notice it. And it's the one most to the right. You okay with that so far? This one was too tiny. I gave it to you. This one over here, I haven't given it to you. I don't think. It might be the 59, but that's the base peak, so I need to double check that question. The other thing to keep in mind is also the formulas and things like that, and I'll show you guys in the next section. Other questions might be like this one here, where I give you a molecular formula, so you know whatever the ion must be is a multiple of the molecular formula. And I'll show you guys some examples, okay? But that's the thing to keep in mind. And for the achieved, it's just one of these two things that I need. So base peak is the easiest one to label. Molecular ion is a little bit trickier, so you're gonna have to use some additional information in the question to probably find it. Okay so far? All right. And the last thing for the achieved, so Charlie, just letting you know, because I did cover this on Friday, so you can kind of see that the assessment isn't too overwhelming, is the CMMR. Now, I will talk about this one on Thursday in more detail. The main thing to remember about CMMR is, again, it can tell us structure of the molecule. For the achieved, all I need you to do is count up how many lines you see here and then state that's the number of carbon environments. So 1, 2, 3, you just write down that there are 3 carbon environments. And that's all you need to do for achieved. So for the achieved, this one's probably the toughest bit, is labeling what functional group you have. So do look over that lesson from the IR spectra, Charlie. And then this one here is dead easy. You just count the number of lines you see. That's 3. And then this one here, you just need to find the base peak or the molecular ion, label both of them. Molecular ion's a little bit trickier, but that's all you gotta do to pass. Okay, we good so far? Shall we keep going? All right, so the next thing that I am then talking about is kind of getting you guys the idea of what this molecular ion and all these fragments are referring to and how does it help you. So we got to look back at the periodic table And we got to look at some of these numbers here. So if you guys remember when you look at the periodic table, I'm just going to draw some just so you guys can think about what that periodic table tells us. It's back in like the day when you guys were doing junior science and stuff. All right. So when I look at carbon, for example, and I break it down into its information from the periodic table, I see that there's a C, I see that there's a 6, and I see that there's a 12.0. What do you guys remember when we're looking at that? The information is telling us that this C is carbon because that's the symbol, and that symbol tells me carbon. 6 protons, so this is my atomic number. And this one down here was the mass number. Say atomic mass. And then atomic number, what does that tell me? Protons. So we say that there's 6 protons. And how many electrons? 6 as well. With the atomic mass, what was that equal to? Protons plus? No, neutrons. Electrons don't count because electrons are really, really tiny, so we don't count them in the mass. So if I was looking at this question here, I would have 6 protons. How many neutrons would I have? 6, because 6 plus 6 equals 12. All right, let's look at another one. Let's look at hydrogen. So hydrogen looks like that. 1 and 1. So what does this tell me about the atomic number? 1 proton, 1 electron. If I'm looking at the atomic mass, what does that tell me? Only 1 proton. Is there any electrons?
No.
Yeah. Are we okay with that? All right, ready for me to kind of blow your mind a little bit? Hold up. I'm just trying to think which one I want to do, actually. I think it's going to be chlorine. Right, so if we look at the periodic table for chlorine, I'm doing the different color just to prove my point. So chlorine is Cl. When I look at the periodic table, it tells me that the atomic number is 17, but the atomic mass is 35.5. So what does this tell me so far? 17 protons, 17 electrons. So something is wonky here, right? It's not a whole number. Can I have a fraction of a proton or a fraction of an electron? Or sorry, a fraction of a neutron? No. So what this is telling me is that we have an isotope. So what that is the same element with different number of neutrons. And so what this number here is just representative of the average of the different isotopes, which is what you guys see on the little table that I gave you. I'll let you guys copy that down and then I'll show you guys the table. All right, keep going. Yeah, Brooklyn? Okay. So these are an example of a list of different elements and their common isotopes. So we can see that, you know, the vast majority of carbon is carbon-12, and 1.1% of it is carbon-13. So that means it has an extra neutron. When it comes to averaging it, though, it averages to basically 12, which is why we see 12 here. But we were looking at chlorine over here as our first example. So chlorine, 75% of it is chlorine 35. So if I had chlorine 35, I would have 35 minus 17, 18 neutrons and 17 protons. So that's chlorine 35. Yeah? Chlorine 37, however, we find 25% of the time. And what that means is that in this case, it has 2 extra neutrons. So it has 20 neutrons and 17 protons. So it's basically plus 2. And if we did an average of that, I can show you guys on the calculator. Just make sure it's bright enough that you guys can see. So if I took 35 and I times it by 75% and I added 37 and I times it by 25%, you see how the average is 35.5, which is what's going on the periodic table. So the periodic table is just the average of the isotopes. That's why you don't always get a full number. So in spec, it's really important that we know which one we are dealing with because the mass spec is accurate enough to show different isotopes. So let me show you what that looks like on the mass spec. So here's an example of a mass spec. This one here is chlorine, and the way you're going to be able to tell chlorine is you're going to look for the mass spec. When we talked about IR, I said for the IR spectra, it's really hard to see the halogens, so I wouldn't expect you to find them on there. I would instead expect you to find the halogens on the mass spec. So I'll write that down as a note. Find halogens on mass spec instead of IR. So what you're going to look for then is you are going to look for basically a tower and then a tower that is plus 2 away from it that is roughly 25% of the size. Sorry, I should say a third of the size. Because that's 75 and that's 25. So we see these towers that are 2 next to each other. Again, we see these towers here that are 2 apart and about a third. So that's how we find chlorine. So we find chlorine on mass spec. You'll have towers. You'll have like a peak and then a peak, and this will be plus 2 and a third the size. So that's how you'd find it. You okay with that? All right, keep going. All right, the other one that you might be expected to find is bromine. So bromine has 2 versions as well. It has a 79 version, and it also has an 81 version. So again, we're looking at something that's plus 2. In this case, when we look at the amount of the isotopes, it's 50-50 almost. And so what you're going to see with bromine is you're going to see 2 peaks that are basically towers of each other. They're going to be right next to each other. The difference between these 2 peaks will be plus 2. And the towers will be roughly the same size. So that's how you'd find bromine. So when you go to write it, the smaller of the 2 is the molecular ion, and then the plus 2 is just showing the molecular ion's isotope. Okay with that? Yeah, so you're looking for those 2 peaks. Because it has 2 extra neutrons, is all it's saying. Right, we okay? Moving on? All right. All right, let's go back to question number 1 then and start looking at this data and how to get up to the merit level. So in order to get it up to the merit level now, we need to start thinking about what the ion is. So an achieve level student just tells me what the data will tell me. So A, you tell me the data. Identify info. If you are trying to aim for the merit level, you need to figure out the molecule. So again, what you're going to have is a huge jump between the achieved and the merit. We good so far? Okay. So what I do when I'm looking at this information is I know my molecular ion and I know my functional group. So what I like to do to make my life easy to try to figure out how many carbons there are is I write my hypothetical functional group down. So I write my alcohol, and I'm going to assume that it's on carbon number 1. And then I don't know what is it attached to. Are you okay with that so far? Can't see it. I can see it. Good. What's that mean? Up where? That? Yeah. Achieved is identifying the information on the sheet. Merit is figuring out the molecule. This is where the puzzle comes in. Can you move it down? Okay. All right, so what I suggest you do is from the IR spectra, just do a rough number of the functional group. So in this case, I see that I have oxygen. So I would look at my periodic table and I would see oxygen has a mass of 16. And then I would, let me clear that so we can start over. 16. And then I have 1, 2, 3 hydrogens. Each hydrogen's worth 1. So I'm going to add 3. And then I have 1 carbon, which is 12, because we want the masses. Plus 12. So that tells me that this fragment here is 31. Do you want me to repeat it? R is just the chain, so I'm trying to figure out how many carbons there are. Are we good? Okay. Keep going? No? Okay. So what I did for this section here is I knew I had an alcohol. I assume my alcohol is on the N carbon. I don't know if it is, but I'm just, for hypothetical sakes, I'm assuming it's at the end. If I had my alcohol at the end of the carbon, I would have 1 carbon, I would have the OH, and I would have 2 hydrogens at the end. Okay? I don't know what my carbon chain is, so I'm trying to figure out what my carbon chain is. So I know there's something in the middle, and then it should have some sort of hydrogen at the end. Are we okay with that so far? All right. So this here is 31. So what I can do is I can take 116 minus 31. That gets me 85. And I know the N carbon has to have an extra hydrogen. So you know what I'm going to do? I'm going to subtract 1 as well, just to account for the hydrogen at the end. Are we good so far? And I have 84. Now, everything in the center of this, if I think about what I have, I should have a carbon with 2 hydrogens attached to it, correct? What's the mass of that? 14, because the carbon is 12 and then I have 2 hydrogens, so that's 14. So if I do, so we had 116, I subtracted the 31, I subtracted the 1 from the end, and I get 84. If I divide 84 by 14, that'll tell me how many carbons I need. Yeah. Oh, yeah. Do it again? No, that's fine. Okay. Start over? Okay. 31. Are we okay with 31? Yes. Are we okay with where I got this 1 from? Or do you want me to go about it a different way? There's 2 ways I can go about explaining this. I'll do one. Do you want me to do it the other way? Yeah. Okay. So I know my answer is 31. I'm going to keep adding 12 until I'm 1 away from 116. Sorry, I'm gonna keep adding 14 until I'm 1 away. Because that 14 tells me a carbon with 2 hydrogens. Yeah? So if I do 31 plus 14, I get 45. So then I add another 14. I'm at 59, still not there. Add another 14. I'm at 73. Add another 14. Another 14. Because I want to get to 115. So I should have 1, 2, 3, 4, 5, 6, plus the 1 hydrogen at the end. 116. So what that tells me is that this chain is 1, 2, 3, 4, 5, 6, 7. There are 7 carbons. $14 came from here. Okay. The other way you could do it, the way I was trying to show you guys initially, is we can take 116, we can subtract 31, we can subtract the 1 that's at the end for the hydrogen, and I get 84. And then I can do 84 divided by 14, and that tells me 6. Do you want me to do that again? Okay. So we can start with 116. I'm subtracting 31. And then I'm subtracting the 1, because that's assuming a hydrogen at the end. So 84 is what I have left over. Now if I do 84 and I divide it by 14, because this is the number of carbons. So 84 divided by 14 equals 6. So then I have this carbon here, so I have a total of 7. Both ways get you the same answer. Okay? And from there, you can start playing with the molecule and figure out what options. So basically, what this is telling you is you can start figuring out potential isomers that fit that condition. So you want, as your knowns, you have an alcohol and you have 7 carbons. So you can make as many isomers that you want that fit those conditions. And there are a lot of choices. There's probably heaps, because you have the branches and stuff. Are we okay with that? Okay. Do you want to see another one? Do you guys want a break? No? Yes? No? Maybe? Huh? You want to put that back? You want a break? Okay, we'll take a break. All right, so looking at question number 3 in your packet, what does the IR tell us? What? It's an amide. I know that because I'm looking at 1700, I see a peak here, that's C double bond O, and then it has this really deep trough with the double peak that tells me NH2, so it's also a primary amide when I look at that. Okay. Do you guys want me to, that one's 2 carbon environments. So if you want the achieved, we write down 2 carbon environments. See, you guys can do the achieved now. All right, and then you guys were looking at this one here. Oh, it's too bright, you guys can't see anything. There we go. We were looking at this, and I remember debating with you guys about the molecular ion and the molecular mass, and in fact, you are right. It is the molecular ion and the base peak. So this one here is our tallest peak, so that's my base peak. This one is also going to be my molecular ion. It's the furthest to the right. I know some of you guys saw this guy here, and we're like, is this the molecular ion? And this is the challenging thing. If it's small like that, it may or may not, so you have to use the other information to help you. So one of the other bits of information that I use to help me is that I know that nitrogen, if it's in the molecule, the molecular mass should be an odd number, and 59 is an odd number. whereas 60 is not. So that tells me that this is also the molecular ion. And I'll add that as a side note because I know you guys are going to want that. Odd number confirms presence of nitrogen. All right, so if you went through and you labeled that, you've passed. Keep going. All right, so now let's start off with my hypothetical, what's my functional group, what's the mass of that functional group, and then figure out how much I need to add to get to my mass. So if I was to draw an amide, it would be C double bond O, and then assuming it's at the end, NH2. And then this carbon's attached to the carbon chain, whatever the carbon chain is. That's my big question mark. Are we okay? All right. So first thing I do is I'm going to figure out the mass of that section there. So I have my oxygen, which is 16. I have my carbon, which is
12.
I have my nitrogen, which is
1. 0.
If I look, nitrogen atomic mass, 14. And then I have 2 hydrogens, so plus 2. So this here is 44. So if I have 44 and I add 14, I have 58. And then am I 1 away from the base peak? So if I add my extra hydrogen, I would have 59. So how many carbons are here?
1.
2. Because we have this carbon and then we have our CH3. This molecule is actually really easy. It's CH3, C double bond O, and H2. There's only one answer for that one, really. Because you know it can't be, well, I'll talk about that when we get to the excellence point. I don't want to worry you at this point for it. All right, we okay? Move it? All right, I just want to show you one more type of question just so you guys are ready for it. And that's if, we'll go to question number 9. Yeah? Do you guys remember in question number 9 how I said when you guys look at the IR, sometimes the IR is really hard to kind of tell what the functional group is? So like with alkenes and alkanes and stuff like that, and then the halogens. So when something is hard, what I'm going to do is I'm going to give you guys a hint with the empirical formula. That empirical formula is a simplified ratio. So what this tells me is that this is a multiple of that. So whatever my molecular formula is, it's a multiple of this guy here. One of the things that I can do to check to figure out what the functional group is I check the ratio between carbon and hydrogen. So I know if my number of carbon is, oopsie, that's not what I wanted to do. My number of carbon, if my hydrogen is twice that number, then that is an alkane. If my number of carbon is the number of hydrogen plus 2, sorry, that's an alkene, my bad. That's an alkane. And it has to do with the fact that I've removed 2 hydrogens to form the double bond. Yeah, sorry. That's an alkene. It's an E. Okay. So when I look at that, what does that tell me? Alkene or alkane? Alkene. From that information. And what I can see here is 3,000, I have the CH. And when I look at 1,700, which is right here, there's no C double bond O. We agree with that? All right. When I look at this guy down here, I can see my base peak, can't I? Because I look for my 100%, and it's that guy over there, which is 56. Now we gotta figure out which ones are a molecular ion, and we're like, ooh, is it this guy? Is it this guy? Is it this guy? Is it this guy? There's lots of things to the right that are potentially it. So basically I'm deciding, is it this one or this one? Do you guys see what I'm saying? 'Cause it's the most to the right, so it's the unbroken molecule. So what I'm gonna do is, to figure out which one it is, I'm going to look at this formula and I'm going to do multiples of that formula. So if I have 12 times 3 plus 6, the mass of the empirical formula is 42. So I'm looking for multiples of 42. Does that make sense? So let's say I do 42 times 2, I would expect 84. Yeah? And what I'm looking for here, I actually see that's 80, 81, 82, 83, 84. So this one must be my molecular ion. Oops. You see how I got there? So I must have taken that formula and times it by 2. So if I give you an empirical formula, that's a hint. So you know whatever your molecular ion is a multiple of the empirical. So it's a little bit of a shortcut. And since I've given you the empirical formula, and we know it's times 2, then I know what the molecular formula is. I know it's C6H12. So then I know what I'm working with. And again, if we're trying just to get to the achieved, we can go through and count. That's 1, 2, 3, 4, 5, 6. There's 6 carbon environments. So that'd be enough to get an achieved. We good? All right, I'm going to stop it there because I think I've probably done enough. And as you can see, you guys are kind of glazing over. What I want you guys to do, though, is practice this. So let me pull up the Google site to talk about what your options are when it comes to practicing this. So going to Spec. We're doing lesson number 2 because we haven't finished it. All right. So we've copied down the notes. So what you guys can now do is you can work on the packet of questions that I've given you, and if you want, you can just focus on identifying functional groups from the IR spectra and then figuring out the carbon number based off of what I was talking about today by the adding 14. So if you want to do that, you can do that, and that would be basically on track for an achieved. If you feel like you've mastered that and you want to get up to the merit or excellence level, you have 2 choices on how to do that. The first one is to go back to lesson number 6 in the organic chemistry and do those structural isomer NCA exam questions. It is a different standard, but the thought process that you're using for that is what you'll need for the merit and excellence for the internal anyway, so it doesn't hurt to practice it that way. The other thing you can do if you want to aim to get merit or excellence is once you have the information of the function group and the number of carbons, you can draw the different isotopes that are possible with the criteria that you've met so far. So like when I'm looking at this guy here from our first question, we know it's an alcohol, we know it has 7 carbons. So what you can do is draw different isomers that have 7 carbons, branched or straight chained, that have alcohol in there. And then when I talk to you guys on Thursday, I can show you how to figure out which of those isomers is the right answer. So those are your choices. And we have about 15 minutes left. Do you guys want to use any preferred activity time and chill for the last 15? Or do you guys just want to work? You want to sleep? We need a collective decision from the group. Want to use it? Over there? Happy to use it? Want a break? All right. Do you guys want me to move on to the CMMR on Thursday, or do you feel like you need some time to process this first? What does that mean? Process? Or do you want me to give you the next bit of information? You want some processing time over here? Over here, what do you guys feel like you need? Some processing time? All right, so we'll put Thursday aside as processing time so you guys can just get the handle of this. You guys want to use your preferred activity time from what the consensus is. So you guys have 15 minutes of free time, and I'll take it off from your time. Okay?